Okay, start.
Alright then guys, we're going to find the area enclosed by an ellipse. This is the standard form, and it is x squared over a squared plus y squared plus over b squared is equal to 1. In order to find it, we need to know that the curve is symmetric about the x and the y axis, right here. And to find the area, we need to find the area of the first quadrant and multiply that by 4. It follows that the area of the ellipse is 4 times the integral from 0 to a of y dx. So first we need to solve for y from here. So if x squared over a squared plus y squared over b squared equals 1, we know that y squared over b squared is equal to 1 minus x squared over a squared. And that equals y squared equals b squared minus b squared x squared over a squared. And finally, y is equal to the square root of b squared times 1 minus x squared over a squared. And so then we follow it over here. We substitute what we got right here back for the y dx. And so then we just solve for it. So it'd be 4 times the integral of 0 to a times the square root of b squared over a squared minus x squared over a squared dx. And we got this because 1 is equal to a squared over a squared. And we just subtracted it, made it together. So then we went from here to here. We factor out the b squared and the a squared. And the square root of a b squared, a squared is always going to be b over a. So we finally get this, right? And then we get this. So it'd be the area of the ellipse is always equal to 4 over b over a times the integral from 0 to a of the square root of a squared minus x squared dx. So in this function, we let x equal a sine theta. And so when we do the derivative of both sides, we get dx is equal to a cosine theta. And so when we let x equal a, our theta becomes pi over 2. So that changes our limits of integration. And when x equals 0, our theta becomes 0. So the area of the ellipse is 4 times b over a times the integral from 0 to pi over 2 of the square root of a squared minus a squared times sine squared theta times a cosine theta d theta. And so since we know the identity of cosine squared theta is always going to be 1 minus sine squared theta, we can substitute that back into the formula and change it from here to here, which would be the area is equal to 4 times a over b times a times b, the integration from 0 to pi over 2 cosine times cosine theta d theta. And so then that equals 4 times a times b, the integration of 0 to pi over 2 of cosine squared theta d theta. The identity of cosine squared theta is equal to 1 plus cosine 2 theta over 2. And so then we substitute that in here, and then we just simplify it a lot more. 4 divided by 2 is 2. So then the area is 2 times a times b of the integration of 0 to pi over 2 of 1 plus cosine 2 theta d theta. We integrate this and we get 2 times a times b of theta plus sine 2 theta over 2, evaluated at pi over 2 and 0. And when we solve that, we get 2ab times pi over 2, and then that cancels out the 2's and 2's, and we get pi ab. And you just substitute your a and your b with real numbers, and that's the formula to get the area of an ellipse. My name is Raul Garrid, and my partner
is Siyao.
Yeah, and that's our video for Math 190.
Okay, thank you.